High School. We are here to assemble and present to you the robot called MBOT, which has been categorized under programming and coding. MBOT is designed for learners to make use of STEM at an early age. My name is Theresa from STEM. Our robot is going to be assembled to perform 4 main tasks, which is the line following, obstacle avoidance, manual molding,
controlled by external devices such as laptop to enable it to move forward, move backward, and play a sound and an action take place.
Our robot has 2 main parts, the electronic modules and the mechanical parts. The electronic modules consist of the base control board, the various sensors, which helps program the mechanical parts to work. So at this point, we would like to take you through the various parts.
We are going to start with the metal base plate. This is the metal base plate. This is where it is a mechanical part, which all the mechanical part is going to be built on, and the electronic modules, and also the line follower sensor. This is an electronic module which helps to control the line following mode. It works by emitting infrared light and recording how much is reflected back. If a little is reflected back, then it can be now deduced that the surface is black or the sensor is not near a surface. And it's having 2 sensors which detect white surface within the range of 1 to 2 centimeters.
This is the ultrasonic sensor. It enables the robot to avoid obstacles.
This is the control board. It is also known as the M-core. It is where all the activities of the MBOT take place.
We will start by building all the mechanical and the electronic. So now you're going to start by building the TTJ motors on the metal plate. Because we can't leave it like that, you're going to tighten it by using the M4 screws. So next, you put the fuse to the tiles so that you put it on the TTJ motor for it to move properly. So as we did the other side, you're going to face the other TTJ motor on the other side of the metal plate. So after fixing the TTJ motor on the metal plate, you continue by building the tiles to the TTJ motor's gear, which will be like this. You will now continue by building the line follower sensor together with the front wheel. And it's fixed by putting the front wheel in the middle hole of the line follower sensor, which will also be like this.
After fixing our line follower and front wheel, next up is our ultrasonic sensor. As I said earlier, it helps the robot to avoid obstacles. So you turn it and you fix it into these 2 holes on top of the smiley place.
After the 2 sensors has been built on the metal plate, we are going to put this cable, which is called the RJ25 cable, which connect the sensors to the M-core, which is the Arduino Based board. So you will insert this in this port of the sensors. You insert it inside. So when you hear this kind of sound, then it means that it has been fixed properly. So now we are going to pass all the cables from the bottom of the metal plate to the upper part. So you pass the TTJ motors on these holes. Then you put the line follower sensors also cable. This is like it.
So that is the stand of the control board. It is to prevent the control board from falling. We'll be placing it in these holes. They are 4 in numbers. After that, we'll be pasting the magic tape on the metal plate. It is to hold the battery holder on the lamp.
The magic tape is used to hold the battery holder firmly on the metal plate. So now you're going to put it on the metal plate. So you first tear this thing that helps.
This kind of tape can stick on both sides, so it's called the magic tape.
We will fix the Bluetooth, which enables us to connect the MBOT to our piece.
The Arduino Based board is fixed together with the Bluetooth.
So after that, we will be facing the battery in the battery holder. It is used to power the whole robot.
You're going to match or put the cable, the RJ cable, on the left and right side. So the ultrasonic sensors will come on the right side, and the TTJ motor and the line follower sensors cables will also come at the left side.
We will then face our Arduino Based board on it.
We're going to screw it together by using the M3 screws. So after the Arduino Based board has been built on the metal plate, you're going to now put the RJ cables of the various sensors to the Arduino Based board.
We will be putting the left motor's cable into the nearest hole and the right side cable into the far hole. And then the line follower sensor will be placed in the port 2. And the ultrasonic sensor will be placed in the port 3.
So after all the cables has been put into their various ports, you will now insert the batteries also on at the back of it. So after we have finished, now we are coming to start with whether if our project has been done properly. So this sound and the diodes now mean that our project has been done properly. So we are coming to test it by using the RI remote control.
This is the IR remote control.
As we stated from the introduction that we are coming to assemble our robot to perform 4 main tasks, which is the line flow rate, the manual mode, obstacle mode, and control by other devices. I'm going to start by controlling by the line flow rate. So we'll start testing the line flow rate mode. As we stated that the A is used to turn it to the manual mode, B, obstacle avoidance, C, line following, and the rest of the button will control the robot manually. So now you're coming to test for the line following sensor. So you're going to press on C. So now it will now reveal that because of the infrared light and how it has been recorded back, now the robot can detect that the surface that is roaming on is black. So now you're coming to test for the obstacle avoidance. Avoiding obstacle by its own, and it's measuring the time between the emitter and the receiver. So it's returning back by not hitting the obstacle because it has measured the time between the emitter and the receiver. With the help of the ultrasonic sensor, we are about to test for the obstacle avoidance. So now you're going to press on B. So you're going to measure the time between the transmitter and the receiver. So what has been can be able to measure the time between the emitter and the receiver. It will not hit the obstacle, but it will rather, the ultrasonic wave will order bounce from the obstacle to the receiver, because the transmitter was emitting the wave, so because it cannot penetrate through the obstacle, it will now bounce to the receiver, and so the receiver will send the command to the M4 to give the M direction, whether to move left, right, or about.
Wireless. It's used to connect the laptop to the MBOT to program it. So now we are going to connect our wireless to our laptop. If the wireless is being connected, the blue blinking light will pause. So after the blue blinking light is paused, it means that our wireless is busy. So in programming, there are various columns in using. First, the event. The event is used to give a certain key where the function should take place when that key is being pressed. So for now, we choose that when key B is being pressed, and we go to the action. It should turn the left wheel. When the key B is being pressed, it should turn the left wheel 100% of power, and the right wheel 50% of power. And we now show a light off. You choose the light from the show column. So we show a green light. And then we will now choose the sound it should play. So it should play C4 sound at the beat of 1. So now we are going to test whether this will really work. We'll first connect the MBOT to the laptop to the MBOT. So you hit on the connect button and you choose 2.4G, and we then connect the wireless serial. After it's been connected, we can now control our MBOT. So when we press the B button, it will then turn the left wheel 100% and the right wheel 50%. So this means that the left wheel will be moving more than the right wheel. So now we are going to test it again by giving it a certain distance for it to go. So the distance will be 1 second. It will move forward at power. If I press the 2 key, it will move our MBOT backwards at power 80 and for 10 seconds. So I'll then press the key 2. So when our MBOT stops, it means that the time is then up. And I'll also press the key 1, which will move our MBOT forward at power 80 and for 10 seconds. If the MBOT also stops, it means that the power is also up. We'll then control it by a given direction. So now we are going to send it back. And when it's going by, it will show a blue light. And we then pause it. Whenever the MBOT pauses, it shows a red light. So this means that the MBOT is being paused. When I also press the up arrow key, it will move forward and it will show a green light. So I'll then press the up arrow key. And we then pause it again. After that, we'll turn our elbow to the right. And in this, I'll be using the right arrow key. The right arrow key will turn our elbow to the right direction. And to show a blinking yellow color. So I'll press blinking green color. This shows that our MBOT have been able to work. So now we'll be making the song play, the MBOT play a sound. So in this, I program the MBOT to play a sound when the A key is being pressed. So when we press the A key, it will then play a sound.
So this is the end of our project. Thank you all.
Thank you for having time for